Alright, welcome back. Today I'm going to be going over this absolute value question that is going to be probably on the SAT, right? Especially that second module. Um, so I don't want to waste any more of your time, so let's get right into it. Of course, give this problem a try yourself. Use Desmos, right? If you want to. Um, but let's explain. So here, right, it's a pretty simple question. It's just asking us which of these four choices gives all possible values of k, which is this constant here, for which the equation has no solution. So essentially, what they're asking us to find a range of k where um, if that was the number, if that was a value for k in this equation, it wouldn't hold true, right? It wouldn't be true. It would have no solution, right? Initially, um, you might start just expanding this right away, right? Mathematically, but in my opinion, because you're trying to save the most possible time, especially on that second module, where the questions can become really uh difficult in only a matter of a few minutes, I would like try to solve this in the most efficient way possible, right? And of course, we're allowed to use Desmos on the SAT. So what I would do is take this equation, type it into Desmos, um, not in the way that you think. Just don't type this exact thing. It's not going to show you anything if you do that, right? Instead, make it a system of equations. So set this part equal to y, and this part equal to y, right? Therefore, you can see where um, those two equations actually intersect or don't intersect, right? So set that here. So we have 5 halves, right? Minus 4 times the absolute value of 3/5. X minus 1 half. Okay, so that's the first one, right? Remember, say equals y, right? And it's a good idea to just double check yourself, right, when you're writing these equations down, because sometimes you do it so fast and you're under pressure and it messes you up. But likewise, let's do the same here. So 9 over 8 minus 2 over 3, k equals y, right? Um, Actually, when you write k, it's gonna have the option to add the slider. Do that, right? Because it's a constant. Um, Equals y. So now, so again, we have our slider here, and we have given the two equations. So now we have to find the range of k where these equations don't have a solution. So what does it mean? What would that look like visually if these two did not have a solution? Well, I set this up kind of in a system of equations way, right? So if you think about system of equations for just a second, you recognize that a system of equations only has a solution if the two graphs intersect, right? If the two functions or equations intersect with each other. So in this case, if we're looking for no solution, we're looking for the values of k where that makes these graphs not intersect each other, right? So if you look at all the answer choices, you'll see that all of them have a 33 over 16, a negative 33 over 16 in common. So let's put that in first. So we've put in that value in, and what you'll realize is negative 33 over 16, if you put that value for k, it actually does intersect with these graphs, right? There is a solution because these two graphs intersect. So right away, that means you can actually cross out b and c because this these less than equal to greater than equal to signs implied that k cannot be negative 33 over 16, right? But that's obviously not the case because you can see that they intersect here, right? The two graphs intersect. So you can cross out B and C. So now you're left with these two. Um, we're looking for values of k more than that number and k less than that number. So now what I would do is type a number just to experiment and see if the graphs collide with each other or don't. So let's look at a value greater than negative 33 over 16, right? So in this case, let's just try something like negative, again, greater than, right? So negative 3 over 16. you will see that that does intersect, right, with the graph. In fact, there's two solutions. So again, A is not the right answer either because those two graphs intersect. We're looking for no solutions, right, where the graphs don't intersect. And of course, that means D is our answer. But just to double check, let's say, let's put a value that's less than negative 33 over 16. So let's put negative 36 over 16. You'll see that now they don't intersect with each other. So of course, that means that D is our answer because there's no solution. So hopefully that made sense, right? I think this just goes to show you how important using Desmos is, especially for these constant questions, right? Because you have to learn to be as efficient as possible with your time on the SAT. But if you have any questions, leave it down, and I'll see you next time.